Hey everyone, welcome to this video. We are going to talk about learning rate. So earlier on in this course, we talked about gradient descent, which updates the weights, and we could have minimized the loss sooner. Here we went from 0 to 3 to 2. So once our weight values is 2, we have an optimal or minimal loss of 0. But we could have done this with just 0 to 2. So instead of doing two weight update operations, we could have just done one weight update operation. So in this video, learning rate is about updating the weights in this training process for the model. What I want you to remember from this slide is this. The weight update rate is important for training because if we had a better weight update rate here, we could have saved an extra weight update operation. And in deep learning, this is called the learning rate. What happens with a small learning rate or if the learning rate is too small? Small learning rate means slower learning. So instead of two weight update operations or one weight update operation, since we have a small learning rate here, we have to do 10 weight update operations. Not very good. Also, you may find the local minimum and miss the global minimum, meaning the model could perform better. So here, instead of a parabola shape, we had like this multiple mountains kind of thing. Anyways, notice that there's two minimums, and we want this minimum because it has a smaller loss. But because we have a small learning rate, it gets stuck on this minimum, and it could have had a better or lower loss here. And if we had a larger learning rate, maybe it could have hopped over this, so to speak, and found this at some point. What happens with a large learning rate or if our learning rate is too big or too large? A large learning rate can skip a minimum entirely. So here we decrease the weight values or go to the left and the loss gets smaller and smaller. And ideally we want to hit this point. But here, instead of going to the left or decreasing the weights by a little bit, it goes too far to the left because of the large learning rate and misses the minimum. Earlier on in the course, we ran a model for classifying images of digits. And here, I specified a learning rate of 0.1, which was good enough to get us a 97.5% test accuracy. Let's talk about adaptive learning rates next, which can automatically adjust the learning rate. I find this pretty intuitive to understand. Example could be practicing shooting with a bow and arrow. So initially, you might be far from the target or you miss the bullseye by a lot, so your aim is going to need to change by a lot. But as you keep practicing and shooting, you get closer to the target and closer to the bullseye, so your aim will only need to change by a little bit. And the Atom Optimizer makes use of adaptive learning rates. Later on in the course, we will learn about LSTMs, and in this LSTM.ipynb file, we will make use of Atom right here. And as you can see, I made the learning rate a lot smaller, 0.0001 instead of, well, 0.1 right here. Okay, that's it for this video. Thanks for watching.